trigonometry and geometry, and we're going to be deriving this equation sine square x plus cos square x is equals to 1. Along with this, in your AS level, you have seen one more identity, which is tan theta is equals to sine theta over cos theta. Okay, so let's derive this identity right over here. So let's say this is the angle theta. This is going to be opposite, adjacent, and hypotenuse. Now, using Pythagoras' theorem, we can say O square plus A square is equals to H square. And then what I'm going to do next is I'm going to divide the entire equation by H square. So we know O over H is equals to sine theta, and A over H is going to be cos theta. So if you take O square over H square, that's going to be sine square theta, plus A square over H square is going to be cos square theta, and H square over H square is just going to be 1. So there you have it. Okay, so that's the first part. Now let's look at the graphs of sine square theta and cos square theta. Okay, now we're going to be looking at the sine square x graph. So we're going to be seeing the domain, the range, and the periodic pattern. Now the domain is going to be your x-axis. If it's restricted, where can we find this graph on the x-axis? And then the range is going to be, where can we find this graph? What's the limitations? Like what regions can we find this this graph on the y-axis? So the domain of this graph is going to be minus infinity to infinity. And the reason for that is that this graph is going to extend to infinity on both sides of the x-axis, the negative and positive. Now, for the range of this graph, this is going to be 1, and this is going to be 0. So it's going to be between 1 and 0, right? There's no value outside of this range. So it's going to be between 0 and 1. Now for the periodic pattern, what I'm going to do is you can see that the pattern repeats. So this is the pattern, and then it repeats again. It's like a hill pattern. So again, same thing here, and then it repeats again. Okay, so we want to find the periodic pattern. So what I'm going to do now is I'm going to take the sine square x, and I'm going to take the x value and y value. So x, I'm going to put 0 degree, 90 degree, 180 degree, then I'm going to put in 270 degree and 360 degree. So once you plug it in, you should get 0 degree as 0, 90 as 1, 180 as 0, 270 as 1, and 360 as 0. So this is going to be 0 degree, this is going to be 90 degree, this is going to be 180 degree, this is going to be 270 degree, and this is going to be 360 degree. You can see that the pattern repeats every 180 degrees. So 180 or pi, every pi it repeats. Right, so every pi radian. Okay, now we're going to be looking at the cos square x graph. So we're going to be seeing the domain, range, and periodic pattern for this. Now the domain will remain same, minus infinity to infinity, and the range will also be the same. It's going to be between 0 and between 1. Let's see the periodic pattern for this. So cos square x, x and y, 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree. So at 0 it's going to be 1, 90 is going to be 0, and then 181, 0, and then 1 again. So we're going to have 0 degree here, we're going to have 90 degree here, we're going to have 180 degree here, 270 degree here, and then we're going to have 360 degree here. You can notice the same thing here, the pattern, it repeats every 180 degrees. Right, so the pattern repeats every pi radians. Every pi radian. Finally, we're going to be looking at what happens to tan x, sin x, and cos x when x is very small. So when small angles are used in trigonometric functions, we can make the approximations where appropriate. Sin theta is approximately theta, tan theta is approximately theta, and cos theta is approximately 1 for small theta. Now, I want you to do is I want to take a calculator and switch to radians mode, because radians are a lot more useful than we think they are, more than even degrees. So switch over to radians mode and plug in these two values. First this one, and then this is the next one. So plug them in for sine theta, tan theta, and cos theta, and just notice what happens. You will see that these three things are true, okay? These three approximations that we have made.